Hello everyone, this is Muskan Elahi and welcome to my channel Muskan Elahi Teaches. So students, today we will be discussing chapter number 1 of class 7, that is operations on sets. But before doing that, we should know that what is a set and how we can represent a set, and then we will move towards the operations on set. So by the end of this video, you will be able to know and understand the different concepts of set, and not only that, but you will be able to solve the questions that are related to the set, or you can say the operations of set. So let's begin. A set is a group or a collection of distinct and well-defined objects. So what does that mean? That means that a set has two things. One thing is well-defined object, and the second important concept is that it has distinct objects. So well-defined means the things that are expressible, that are understandable, and the distinct mean that unique things. So when we move towards the example of a set, so a set of crayons in a box is also a set. The planets of a solar system, if I say, it's also a set because it has distinct planets that everybody knows that planets are a part of a solar system, so that is also a set. Now let's move towards the other concept, that is members or elements of the set. So if I say set A is equal to apple, mango, banana. I have written the names of the fruits. So in this set, when we will be saying that how many elements this set has three elements, right? Apple, mango and banana. When we are saying that the elements of a set, the elements of the sets are the objects of a set. The objects in a set are written within a pair of curly brackets. So one thing, when we talk about the elements, so the objects of a set are written within a curly bracket, right? We put the objects inside the curly bracket, and the second important thing is that these objects are members or elements of the set. So this set has three members. Alright, and these members basically belong to the set itself. Apple belongs to set A, mango belongs to set A, and banana also belongs to set A. So this is the whole concept or the idea. So I am continuously saying that these things are belonging, or the objects are belonging to the set. So when we say that belongs to, so it can be represented by a symbol, that is this symbol. Alright, so this indicates or denotes belongs to, or is an element of, or is a member of. I guess so. Till now the concepts are clear to you. Now we'll move towards the three forms of set. So a set can be represented in the three forms that are illustrated in the page that you are seeing, that you are able to see right now. So the first form of set is descriptive form. Descriptive form, when we talk about, is a set that is described in descriptive terms, or that is described completely in words. Alright, let's suppose the example is given to you. Set A is equal to first 5 natural numbers. So I have here explained the set, that the set will be composed of first 5 natural numbers. Now let's move towards the second form, that is set builder form. A set written as a rule. Always remember that whenever we are talking, or whenever we are expressing the set in the form of set builder form, so we will always write this thing. Always there will be the symbol like this in the set when it will be in the form of set builder notation, right? So it is expressed as a rule. Let's suppose मैंने वही example here इधर लिया यहाँ पर. A is equal to first 5 natural number. Initially I described the set in the form of descriptive form. Now set builder form I am taking, and in this I will express the same set in a rule form. How? Let's suppose I have written here that x dot x is a natural number and 6 is greater than x. It means the x, or the value of x, will be less than 6. So this set is the same as I told you the descriptive form, that it was including first 5 natural numbers, but I have here expressed the same set in a different way or the different form. Now let's move towards the third important form, that is tabular form. In tabular form, a set with the elements of the sets written directly. If instead of saying that the set is a collection of 5 natural numbers of the initial numbers, so instead of that, if I am saying that A is equal to 1, 2, 3, 4 and 5, so this is also the same thing, and it is more definable because you are able to understand what are the elements exactly that I was talking about. So these 3 forms of sets are very important and very easy to remember. The first form is descriptive form, in which we describe our set, right? And the second form is set builder form, in which we describe our set in the form of a rule. And I told you that it contains this symbol always. And the third important form is tabular form, and in the case of tabular form, we write the elements of the set particularly. So I hope that till now it's clear to you. And now let's move towards the different forms of sets. Empty set is first, the important type of set is empty set. If a set do not contain any elements at all, then it will be known as empty set. A set containing no elements, it is denoted by this symbol. Here the example is also given. So this kind of set is known as empty set. Now let's move towards the second type of set, that is finite set. Finite, the word finite means that countable. The things that we can count are finite. So finite set will always contain countable elements. If the elements of a set are countable, or you are able to count them, then you will represent that set as a finite set. You will call that set as a finite set. Now the third type of set is infinite. Infinite means not countable, uncountable. So a set which is not countable, let's suppose here in the case the elements are not defined, they are uncountable. You cannot count the till which value I am talking about. So in this case the set is infinite. Now let's move towards the other types. Disjoint set, a set with no common elements. I have here written 2 sets, E is equal to 2, 4, 6 and F is equal to 5, 6, 7. So these 2 sets do not have any common element in them. So this set is a disjoint set. A set which do not have any common elements will be declared as disjoint sets. Overlapping set, a set which have at least one common element. A set which will have one common element, we will call that as a overlapping set. For example, A is equal to 1, 2, 3 and B is equal to 3, 2, 3, 4, 5. So in this set 3 is common. 3 is common in these 2 sets, so it will be declared as a overlapping set. Now the other type is equivalent set. Equivalent set is a set with equal numbers of elements. For example, here in this example, J is equal to 1, 4, 6 and K is equal to ABC. Now if I talk about the number of elements, J has 3 elements and K set is also consisting of 3 elements, but the elements are not same although, but the number of elements are same. So if the number of elements are same in a set, they are called as equivalent sets, right? And now when we talk about equal set, so equal set is a set which contains the same element. Let's suppose in the example L is equal to 2, 4, 6 and M is equal to 2, 4, 6 again. So this set is a example of equal set. Now the second last type of set is a universal set, a set which contains all the sets under consideration. From the universal set, if I am making other sets, then that set that has the element of all the sets, that will be known as a universal set. right? For example, u is equal to 1 2 3 4 5 6 7 and a is equal to 1 2. So in this case, set u basically contains all the sets that are under consideration, so it is a universal set. Now, subset, a set that is fully contained in a bigger set. If a set is contained in a bigger set, then that set is, the bigger set will be called as a super subset, but the smaller one will be declared as a subset of. So in this case, if I talk about over here, a is equal to 2 4 6 and b is equal to 2 4 2 3 4 5 6 7. So here in the case, a is a smaller one and it has all the elements, not all the elements but some of the elements of set b. So b is the super subset of a and a is a subset of b. I hope that it is clear to you. So we till now we have discussed the forms of set, what the set is, the forms of set, the different types of set, and now let's move towards symbols that are used in a set. Symbols used in a set, when we are saying this thing, then the one that is so common is equal to. In equal to, when we are using this symbol in a set, it means that the set has not only the same number of elements but also the same exact elements in each other. So it is equal to, right? I have also given you the example so that you can understand the things so easily and you will not have any problem, inshallah. Now the other is not equal to. So the sets will not equal, when the sets will not have exactly the same elements. We have already discussed the equal set. When we are saying that the set is equal, it means it has or it must have the same number of elements, and not only that but also the exact elements in one another. So if the elements are not same in two sets, then it will be not equal to, it will be an unequal set. And this sign is, it means, we have discussed this, it means is a member of or belongs to. So if I write 1 2 3 set, I have written this set, and if I'm saying that 3, so 3 belongs to this set, so it is written in this way, or you can say that we use this symbol in this way. And the other is not belong to. So if I write a member or some constant number that is not a member of the set, then we will declare or will represent this thing as that, and we say that it is not equal to, 3 is not equal to, or 3 do not belongs to this set. Now one more thing that we have discussed is the empty set or the null set. We we use a symbol for this is that, and when we represent it, it is in the form of curly brackets without any element. All right. Now the other one is a proper subset of. This symbol represents that it is a proper subset of whatever the sets are. Suppose a is equal to 1 2 3 and b is equal to 1 2. So b is a proper subset of a because it contains all the elements of set A. Not proper subset means if it does not contain any member. In this example here you can see that a is equal to 1 2 3, b is equal to 0 4. So b do not belongs to set A, or you can say that it is not a proper subset of. If all the elements are belonging to the set A, then we call it is a proper subset of. If they are not belonging to, then you will say that it is a improper subset. Right. Now the last symbol that's very important is a subset of. So I have already discussed this thing. So a is equal to 1 2 3 and b is equal to 1 2 3. Again, a is a subset of b. Now the last important, not last, you can say we have other concepts as well, but cardinal number of a set. The number of elements of a set is called its cardinal number. Initially when I gave you this example, so how many elements this set has? I told you that it has 3 elements. So 3 is the cardinal number of a set. The number of elements of a set is called its cardinal number. Right? It's very simple and very easy. I hope that it was a useful video for you all. Thank you so much for watching.